The Google Cloud Platform provides several powerful tools for your data analytics needs. In this demo, I will walk you through an example of a data pipeline that begins by extracting data from a REST API and ends with loading the data into GCP's serverless data warehouse called BigQuery. We will visit each of the steps along the way in this pipeline. Let's start with the source of the data. Here's the documentation for the REST API that data will be extracted from. This particular REST API is typically used for testing and prototyping. However, any application's REST API could have been substituted. We're most interested in obtaining the 10 test records associated with the user's resource. By clicking the user's resource, we can see that there are 10 JSON records associated with that endpoint. Let's now navigate over to the Google Cloud Platform's console homepage. As the end goal of this ETL pipeline is to append new data from the API to a target table in BigQuery, let's start by navigating to BigQuery and querying the target table to take note of its initial state. This way, we can compare the results from before and after running the pipeline. I'll click into the dataset, and I'll click on the users table. And here I can run a quick, simple select statement to take a look at the underlying data. And here we see 10 users records that were previously obtained. Next, let's go ahead and navigate to Cloud Functions. Cloud Functions are GCP's serverless compute solution. This service allows you to run your code with zero server management. Additionally, you only pay for what you use based on the function's execution time metered to the nearest 100 milliseconds. The Cloud Function used in this demo was used to create a custom Python routine that extracts JSON data from the REST API we just saw, converts it into CSV format, and writes the obtained data to Google Cloud Storage, which we will visit next. Here's the code associated with this function to perform these actions. If a load and no-code integration or ETL tool is preferred, GCP also offers other options such as Cloud Data Fusion and Cloud Data Flow, which are not used in this pipeline. This particular Cloud Function is scheduled to run daily at exactly 3 a.m. In order to schedule this function to run, we use Cloud Scheduler, which is GCP's managed cron job service. Here, we navigate to Cloud Scheduler, and we can see that its frequency is set to run at 3 a.m. every single day, and that it was last run at 12:32. Let's go ahead and trigger it again right now at 12:40. And here, once I hit refresh on the page, we'll see that the last runtime now reflects the current time, and the result was a success. That means we should now see a file written to Google Cloud Storage. Let's go ahead and navigate to Cloud Storage. Cloud Storage is the object storage solution provided by GCP. The tool is used to create a data lake where raw data extracted by the Cloud Function is stored. Data is organized into buckets, which enables setting different security and access levels on data. Let's go ahead and navigate to the user's data that we just extracted right now. And here we can see the CSV file associated with our extraction. 12:40 is the last modified date on this file, and we can see we received 3.47 kilobytes of data with a file titled users and the current timestamp. Next, let's go ahead and navigate to BigQuery. We should now see in the table that we queried earlier an additional 10 records that were extracted from the REST API. By running a simple select star on this table, I now see that there are 20 records in this table compared to the 10 records we previously saw at the start of the demo. The users table containing raw data uses an external data configuration. This allows you to directly query a CSV file as well as many other file formats stored in Google Cloud Storage. The ability to directly query files containing raw data avoids having to redundantly store both the raw file in Google Cloud Storage and raw data and storing it in BigQuery itself. Additionally, it avoids the use of data manipulation language such as SQL insert or update statements, as a new file is immediately available in the users table based on the table's external data configuration. This data can be further transformed in BigQuery to create a native table, which is more suitable for reporting and ad hoc querying than external tables. This SQL transformation can be set to trigger automatically using a cloud function or with other tools such as BigQuery scheduled queries. In this instance, a SQL statement was manually run to create a native table. The user's clean table is a native table rather than an external table. We can query this table as well, or we can preview it here on this page. Lastly, once the data has been transformed, it can then be consumed by several tools. Among these are visualization tools such as Looker and Tableau, as well as several other tools within the GCP platform. Thank you.